Dear students, welcome to this video lecture on the topic of microscopy, the third video lecture. So till now, those who have not heard and they have not viewed the first two videos are requested to listen to first lecture, second lecture, so that you will have connectivity and you know what is being taught in the regular lectures. These videos would help you to revise and would be very good supplementary content. Moving on, let's begin with the topic, and the learning objectives for this lecture is to explain the concepts of numerical aperture and resolution in microscopy and to describe the different objectives which are used in microscopy. So when you speak about resolution, it's the ability of a lens to separate or distinguish between small objects. So much of the optical theory which is used and discussed in the microscopy topic is based upon the pioneering work by German physicist Ernst Abbe in 1870s. So the minimum distance d between the two objects that will reveal them as a separate entity is given by the Abbe equation, in which lambda, the symbol is not visible here, lambda is the wavelength of the light used to eliminate, and n sine theta. Theta is a numerical aperture. So as the d becomes smaller, the resolution will increase. So finer will be the details which can be discerned in the specimen. So what is numerical aperture? It is actually a bit important technical concept. Theta, it is defined as half of the angle of the cone of light which is entering the objective. So when you recall the second video lecture, I showed you the light microscope. So the path of the light will be from bottom. So light will strike the organism. Once it is passing through the condenser, it will be cone shaped. So when this cone has a narrow angle, it will have a very tapering sharp point. It will not spread out much, and therefore it will does not adequately separate images. So it will have a lower resolution. So if the cone of light has a wide angle, it will spread out rapidly, and closely packed objects would have a better this picture. Now the cone angle that will come into the lens will depend upon the refractive index. Very important thing. You have heard of this physics concept, refractive index of air, water, glass. So the cone of the light ka that particular angle will depend upon the refractive index of the medium. So the refractive index for air is 1 and sine theta cannot be greater than 1. Sine 90 as we know is 1. So the basic problem is that no lens working in the air can have a numerical aperture greater than 1. But we have to have some practical solution. So the only practical way to raise this numerical aperture more than 1 will be to have the higher resolution is to increase the refractive index with the oil. And that is the reason we use a colorless oil, a liquid, which will have the same refractive index as glass. So in this picture you can see, now you know what is the working distance. The left hand picture is different from right hand. You yourself can make out the difference in the cone of the light. Right hand may it is like spreading more as compared to your left hand. The angular aperture theta is half of the angle of cone of light which will enter a lens, and the numerical aperture is n sine theta. Right hand picture, the lens has a larger numerical aperture and angular aperture. You can see the half this angle of the cone of light. So its resolution will be greater and the working distance is small. Left hand pay, the working distance is large. As you can see, it is the distance between the center of the lens and the specimen. So right hand side, the resolution is greater and the working distance is small. So basically this was about the concept of microscopy. Thank you all for listening.